Good morning, people. Getting a few people in. There's someone else in here as well. Um, if you're in, your first job, this should be posted on Classroom, I think, is our role and starter questions. Hello. Oh, we had 7 people, now we're down to 5. Alright. Right. I have a guest presenter for us today. Right, hi guys. Hey, Wazirv. Alright, so as you come in, you're probably going to need to flick between the YouTube tab and Classroom. Okay. I'm looking to see if you could fill in this Google form. Oh, did I post it on Classroom weird or something? Liam, did you get in? Oh, welcome, Kathy and Sahil and Claire and Eunice. Yeah, I might have done something stupid with my link. I don't know, it looks alright. Hello. Is Liam in here at the moment? I have to post the link and not link the link. I don't know, does it make a difference? Seems like it worked for some people. Right, I'm going to reply to him on Classroom. Okay, 8 people have done the form. Just keep on tracking along. The questions should be, I don't know, hopefully not too much of a hassle. Fourteen people, okay. That's weird. Awesome. Okay, if you are done, what you might as well have open is this. Look around on Classroom. Somewhere inside there, I posted this as structure and bonding notes file. Ahayosh. Right, and the reason why we want this is because, well, there's a couple of little basic bits there, but this list, step 1 to 7, that's our Lewis structure plan. Okay, and we're spending most of today just smashing out Lewis structures. Hopefully, we'll be really good at them by the end of it. Oh, hey Liam, you're in here. Okay. What you should be doing if you're in is answer the Google form that's posted on Classroom. This thing. Alright. 10 people have done. How many people are awake? Okay, we're all kind of, okay, mostly kind of awake. That's nice. Okay. How's the first 2 lessons gone? Oh yeah, and I think there's about a 20-second delay on the stream, so there might be a bit of a pause between you typing and me saying something. Oh hey, Tashfiq and Luke. "14 responses, so possibly the people who have just joined the stream just need to smash out this Google form." Oh, hey Tanya. Better than expected. Yeah, it's kind of uncharted territory for everyone, including us, so you know. But if we have to make it work, then we're just gonna have to make it work. The notes file is a separate post, okay? So I'll show you. Bring it up. It is there. March 19th is the post. Hey, Rayhan. Okay, so that post will give you this file. Okay, this is actually part 1 of the topic. You notice was written right there. It's just because the notes file it's already 14 pages, and it gets a little bit crazy if I put the second part on there. A page. If you understand the joke on this, then you've successfully completed part 1, I guess. Okay, Google Form, where is it? Here it is. 17 responses, so possibly the last couple of people joined in. Just need to have a quick look at this. Someone's not awake yet, that's good. And I've got a little whiteboard set up for you guys. How about that? What this is it's a cheap webcam and a clamp stand from school. It's really high tech. So I can't find it. You mean the notes file, Alex? Yeah, I'll probably, if we have to do this for a long time, I'll probably use a mixture of this and Zoom. See how it goes. Hello, Emma. 18 people responded, so if I look at the last little bit, so probably the couple of people who have just joined. Paige, oh no, your page is done. Emma and someone else. What are our answers like? Oh, yeah. Oh, was there the same question in that form twice? Sorry about that. Right, let me turn off the whiteboard. Alright, we're good to sort of get trucking. 19 responses. Okay, we're mostly awake, that's good. Starter question 1. Contains a combination of metal and non-metal. The type of substance. Okay, as soon as you see a combo of metal and non-metal, you're pretty much definitely looking at ions. Okay, so red, that's the right one. If you chose the blue section, a few people did, you're not going to see metal atoms inside molecules. It's just not really a thing. If we made that an absolute rule, I mean, there is actually, like, I can think of one exception to it, okay, which we'll never see. So if you see metal atoms, no way ever going to be a molecule, okay? And then metal alloy, I just put that in there to see if I could trip you up, okay? Metal alloy wouldn't actually have a chemical formula because it's just a mixture of things, okay? Metal and non-metal, instantly ions, okay? And then, oh yeah, that question was repeated twice. Okay, how many valence electrons does a nitrogen atom have? Okay, the correct answer is 5. Okay, a little slither of people went for 4. I'm pretty sure I know exactly what you've done to do that because I put that in there on purpose. Okay, to find the number of valence electrons, you can do 2 things. Okay, you could look at what the atom has and think about the different electron shells. So there's 2 in the first, 8 in the second, and whatever. And once from that, you could work out how many valence electrons it has. Okay, and if you chose 4, I bet what you did was you looked at the square for nitrogen and you saw 14 and 7 as the 2 numbers, and you've used the molar mass and said that's 14 electrons, 2, and then 8, and then 4 is 14 electrons. Okay, you don't do that. All right, just look at the group numbers and essentially just delete the first digit. So nitrogen is group 15, therefore it's got 5, and that's it. Hi Shimron. Okay, and that's the end of the starter question. I think I actually I don't know. There's 2 questions twice. Don't worry about that. Okay. All right. So what we're going to do today is that we're just going to smash out some Lewis structures. Okay, it's going to be pretty much drawing nothing but Lewis structures. So hopefully you've got pen and paper. Okay, you will need to have your screen up because this particular doc that I have in front of you right here has the Lewis structure recipe. 7 steps right there. Okay, so have that loaded up and in the background of your screen, or like split your screen or whatever, okay, because we're going to have a go at doing that, doing a bunch of Lewis structures. And these are probably the best set of sort of starter ones, okay. So have that list, the 7 steps open, and we're going to try and apply that list to these 4 examples. Okay. One of the really important things about these is that you can't cheat and skip bits of a list, otherwise it just gets wrong. Okay. Should I do the first 3 as examples? Do you reckon that makes sense? I'm not sure what you mean there, Liam. Yes, okay, let's smash these guys out. Alright, so let me flick the camera across. Document camera. Alright. What I don't have, okay, let me just, give me a second. I'm just going to make sure that I'm doing the steps exactly as they say. Alright. Step 1. Work out the total number of valence electrons. And remember, the group numbers are for this. Okay, so H2 is going to actually be the simplest Lewis structure you can come across. Okay, there are 2 H atoms. I look at the periodic table, and H is in group 1. It's got 1 electron, 1 valence electron. Okay, so I'm going to have, try and keep that level. Yep. Okay, I'm going to write 1 plus 1 equals 2. Who would have thought? Okay, what that means is that whatever I draw needs to have 2 VE, 2 valence electrons. Okay, that's the end of step 1. Okay, step 2, work out which atom is in the center of the molecule. Okay, this atom is only going to be present once in the formula, and if you have more than one, it's the one with the most room in its outer shell. So there's a few little bits and pieces on that. Okay, the thing about some of these is that, well, if you've got 2 atoms, I mean, you don't really have a center. You've just got 2 atoms joined to each other. So, you know, where there's only 2 atoms, you just have 2 of them. So we're going to draw 2 H's, and we just stick them next to each other. Okay, we can't really say one is at the center and then put the others around the other side because there's only 2. Okay, and then draw the central atom, arrange the others around them. Well, I've only got 2. Okay, and then the next step, in part of step 3, says draw 2 electrons between the atoms. Okay, that is needed because the atoms must be bonded to each other. Okay, the bond is a shared pair of electrons. Okay, if those 2 electrons weren't there, then these 2 H's wouldn't be joined to each other. Okay, so every atom needs to be joined with a pair of electrons as a starting point. Okay, and then next, work out how many more valence electrons needed to be added until I reach the total. Well, the thing about this one is that the total is 2 valence electrons. I've got 2 just from joining the atoms together, so I've got all of the electrons. And the last bit I'll quickly do is pen swap. Okay, we just need to think about whether or not each atom has got a full outer shell. And the thing about hydrogen is that because it only uses the first shell, the full shell is actually 2 rather than 8. Okay, so those 2 H's with the 2 X's drawn between the middle of them, that's it. It's finished. Okay, so your final answer, because my circles kind of mess it up a little bit, is you either do that. You are allowed to replace the shared electrons with a single line. Okay, kind of looks tidy. This is the correct answer. This is a correct answer. I don't really care what you do. Okay. H2O, I'm going to write for my valence electrons 1 plus 1 plus 6 gives me a total of 8 valence electrons. Okay. Oxygen group 16, 6 valence electrons. And that's step 1. Step 2, work out which atom is in the center. Okay, it could be an H in the center or an O in the center because that's what I got to work with. Okay, it's going to be the O. Okay, because step 2 tells you the central atom is going to be in the formula only once. It also says the central atom will have the most room in its outer shell. Okay, if an oxygen atom has 6 valence electrons, that means it's got room for 2 more. Okay, the hydrogen atoms have only got room for 1 more to give them a total of 2. Okay, so oxygen kind of wins on both accounts. Oxygen goes in the middle, and then I'm just going to put the H's left and right. Okay, left, right, up and down, it doesn't actually matter. So if you could draw this vertically if you wanted to, it doesn't make it right or wrong. You know, it doesn't make it wrong. Okay, and then draw 2 electrons between. Okay. It's got to be bonded together, so there we go. Okay, and now step 4, work out how many more valence electrons need to be added to give me the total number. Okay, so what I would do here is I'd look at 8 And I'm just going to scribe that off, and I'm just going to write 4. Okay. The reason why I've done that is because I know I need to have 8. I've already booked in 4 electrons just to hold everything together. So there are 4 left to be put into the picture. Okay, and once I know that, I need to put those electrons as pairs on atoms, and I start from the outer edges and I work towards the center. Okay, and I only put pairs of electrons on atoms that actually need them to get a full outer shell. Okay, so if I look at my hydrogens, well, hydrogen only wants 2 electrons. So once it gets a bond, it's finished. So I can't put electrons on the hydrogen. You know, I couldn't. I've now got 8 electrons. It makes no sense because the hydrogen doesn't need them. So we just don't do that. Okay, but if we can't put the extra electrons on the outer atoms, we have to put them on the middle one. Okay, so that's what I've got there. I've now essentially got 0 electrons left because I need to have 8, and I see 2, 4, 6, 8. If I check my shells, what do I find? A full outer shell of 2 for hydrogen, a full outer shell of 2 for hydrogen, and then a full outer shell of 8 for oxygen. Yeah. So that is a final answer. And those circles, by the way, they're not part of it. That's just me checking. You could rewrite that and have H single line O single line H, but of course you still have to keep these things. Okay, that's 2, 4, 6, 8 electrons still, and that's how you do that one. They seem reasonable so far. The stream is about 20 seconds behind, by the way, so if you type something, I won't actually see it for a little while. Or if I say something, you won't hear it for a little while. Yeah. Yeah, it seems like it's probably easy 30 seconds from me saying something to you hearing it. All right, let's shuffle those guys out of the way then, if you're happy with those. Next ones are the last one's going to be just you guys, but well, I'll go through it, but you would finish it first. Okay, so O2. It's another example where there's no central atom, but we just don't worry about that. Okay, but I am going to write 6 and 6 gives me 12 VE. Trust me when I say that if you don't do that, then some of the later ones you just can't get them right. Okay? Because there's only O's, there's nothing really in the middle, I just have to join my 2 O's together. I go like that. Okay, and I have to get 12 electrons inside there. I've already used up 2, so there's 10 left. Okay, and I'm now on to step 4 for this one. Right, work out how many more needed to be added, 10, and starting from the outer atoms, add electrons until they have full outer shells. Add them, it's called a lone pair. Okay, that just means the 2 x's are next to each other. Yeah. All right, so 10 electrons to go in. So what I can do is it doesn't really matter what side I start on, of course, as long as I start from one of them. Okay, so 10 extras, 2, 4, 6. I can't put any more on there because that's a full set of 8. Okay, so that's 6 extras put inside, 8, 10. Okay, it doesn't matter left, right, up, and down where I put those. I could have put this pair over here. It doesn't make a difference. Okay, but the key thing for this point, and this is what people get, this is one thing that people will just sort of do, is that you can't have anything other than this starting number. Okay, so the starting number, super important. Okay, if you don't actually write that down, then it would be really easy for you to come along and say, oh, it's, you know, now it's finished. The oxygens all have full outer shells. Everyone is happy, but that's 2, 4, 6, 8, 10, 12, 14 electrons. It just can't be correct. Okay, so you can only use what you have to play with. Okay, 10 electrons, all gone to 0. And now I check my shells. And I'm not going to use a pen on this one because I want to move stuff around. But I mean, if I look at this one here, the left-hand oxygen, it's got a full set of 8. Seems pretty happy. But this one here, definitely not happy. It's only got 6. But remember, I can't put in any extras. So what I do is that I don't put in extras. I just make some of the ones that are already there become shared as well. Okay, so if I delete these 2 electrons from this atom, and they now join the middle, everything in the middle belongs to both atoms. Okay, so there's now a total of 4 electrons being shared instead of 2. There's still 12 in the picture, so I haven't broken the 12 number, right? And if I think about shells, that shell has 8, 2, 4, 6, 8, and this one here, 2, 4, 6, 8. Okay, so the oxygen Lewis structure, if I get rid of those circles just because there would be 4 electrons in the middle, couple of pairs on the left, couple of pairs on the right, and that's done. The 4 electrons in the middle, every pair of shared electrons can become one line, so it's actually a double bond. So that is probably the more standard way it's going to be drawn. Okay, the top one is correct, bottom one is correct. You know, whichever you know works for you. Okay, you can even start drawing these lines inside here for the Lewis structure, but it's best not to do it at the beginning because you want to be able to physically see the 8 electrons, and if you're drawing lines, you might actually not count them as being 2. Okay, so CO2 is one for you guys to do. So just give it a go. I'm going to give you about 2 minutes of work time. Okay, and then I'll flick the. We'll go through it as an example. Okay. And Discord. Yeah, I haven't really looked into Discord that much. I wasn't sure how well Discord did video. I thought it was really only an audio thing. I don't know. I have set up Zoom, and I think it will be useful sometimes, but it seemed like this made more sense. I can do more stuff with the cameras, I think, with the stream than I can with Zoom. you doing alright? About another 30 seconds or so. You're definitely going to be shuffling some of those electrons around to fill up the outer shells in this example, aren't you? Alright. So how do you get on? I'm going to say 4 and 6 and 6 equals 16 valence electrons. Okay. Writing the working doesn't really matter. You know, you could probably just add up to 16 inside your head. You know, I'm just spacing it out for you guys. Next step, which is the central atom? It's going to be a unique, which means there's only one of them. So I'm going to go with C, which means I put the O's on the outside edges. An O there and an O there. The C, also with 4 valence electrons, it can fit 4 more inside its valence shell. The oxygens have 6, so they can only fit 2 more. Okay, so the C, central atom, is going to be the one with the most room in its outer shell, which is the carbon, right? Okay, so 16 valence electrons. Step 1, let's start by just joining it together with just single bonds. Drop the 16 down to 12, and then outside edges inwards. We fill up the shells until we run out. Okay, so it's 12 to go in. 2, 4, 6 makes it full. 8, 10, 12 actually also makes it full. Okay, so 12 is now 0. Okay, 16 was a total, and if I double check all that, I can see 16 on there, right? But I don't think it's finished. And the reason why I don't think it's finished is that I think that this carbon is it's a very unhappy chappy. Okay, the atoms inside the Lewis structures are gonna have full outer shells because it's the most stable electron arrangement for them. Okay, this oxygen's got 8, seems pretty happy to me. This one's got 8, seems happy. This carbon only has 4. Okay, and it's forming the molecule to get a full outer shell. Okay, so we need to give it more electrons. Can I just put another couple? It's a very unhappy, yeah, that's right, Liam, it is unhappy. I can't just put in extra electrons to make it, I can't, there's this, I can't do, get them, ran, get them away. Stop, oh, okay. Instead, I can move the electrons that I have available to make it happy. Okay, so let's force this oxygen to do a little bit of sharing. Okay. Now the oxygen still has 8, but now the carbon says you've got 6. And but I need to sort of push it up. Am I making it worse or making it better? Oh, I lost part of my C. It's going well. It's going well. Get back up there. Okay. I need to do that again. Okay. So if I remove 2 from this side and I put those ones so they share as well. Now, oxygen's got 8. There they are. Oxygen's got 8. There they are. Carbon actually has 8 as well. Okay, it's done. The tidier version would be a double line and a double line, and then you have your two lone pairs sort of just stretched out around the edges. That's what it is. Who got it correct? If you make the oxygens share electrons, Shimran, then the carbon will get up to 8. Make both of the oxygens share an extra pair of electrons. Yep, excellent. All right. The next Lewis structure practice that's happening is going to be inside the slides that are posted. Okay, so you should have a post in classroom. Went up today. Structure and bonding slides drawing molecules. Okay, so if you've got that sorted, you might as well bring up those slides. I will flick my screen across to one of the slides, and then it's going to be mostly a case of you guys just, there's a slide 17, 21, and 24, and 29. So there's 4 slides with a bunch of Lewis structure examples, and they kind of go from like, well, there's some slightly trickier ones at the end, okay, but it's not actually that bad as long as you follow the steps. You actually can't get it wrong, all right? But I'm gonna flick the camera across. Here we go. All right, move this thing out of the way. So one of these slides, this is the steps of what you do. Why won't you click? Oh, hold on. Here we go. Oh, happy birthday, Liam. So nitrogen gas, N2. Okay, we have to find the square that says N, and we look at it, and we notice that it's in group 15. So it's got 5 valence electrons. Okay, the total number of valence electrons, because there are 2 nitrogens, is 2 sets of 5, or it's 10. Okay, we have to bond the 2 N's together. Okay, we could draw 2 X's between these, which is what we've been doing so far, but you can't actually go straight to a line. Okay, yeah, Shimran, the double bonding, I don't know, it's once you get it, it's really easy, but a lot of people do get a bit like stuck on that. Okay, so I've got 2 electrons joined between the ends, hold them together, and then to make up 10 electrons, I can put a pair on there, and 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 it actually doesn't matter how I organize those guys. Okay, but I've got 10 electrons, and that's all I have. Okay, look at those 2 nitrogens. They both look very unhappy. Okay, so what I can do is I can delete a couple of electrons, make a bond, but they still don't have 8, so I can delete a couple more and make another bond. In this case, we've got 6 shared electrons. That's okay, because there's still 10 electrons in the diagram, and now every atom has a full outer shell. Okay, so what I want you guys to have a go at, just with pen and paper or whatever, is do some more Lewis structures. Before we do that, these, these actually have quite a useful point to them. Okay, and what they tell us is that they allow us to predict certain features about the substance. Okay, the Lewis structure will tell you the exact shape of the molecule. So you might possibly have already come across pictures where a water molecule is kind of like a Mickey Mouse ear with it's like the central atom, and then there's the 2 ears on the top of it. Okay, that comes from a Lewis structure. Okay, the Lewis structure will predict how it could react with other stuff, and it will predict physical properties of something. Like, will it be soluble in water? What is going to be the boiling point or melting point, and so on. Okay, so they're pretty useful things. So have a go at doing some things. Oh yeah, by the way, your chunky SciPad, and around about page 40 is where the Lewis structure practice kicks in. Okay, so have that sort of booked in, back in your mind, page 40 to 43, your homework pages. Okay, I want you to have a go at drawing those guys. Okay, so each Lewis structure is about a 1 minute drawing. Okay, so just smash those out, and yeah, don't forget to like and subscribe. My year 10s wanted to know how to donate money, but I don't know what I do to make people donate money. There must be something I turn on or something. But I'm not going to do that. This is weird, man. I don't know if I like it. Yeah, I actually have another channel called Mr. Chemistry NZ. I haven't used it for a few years. I did have ads turned on, and I earned about $20, but then they disabled the ads somehow. Well, they changed the rules, so if you didn't have a certain number of subscribers, you didn't get any more ad money or something. Yeah, it got demonetized, but I don't think I did anything wrong. It was just that they changed the rules, and I don't know. Not that it ever mattered because I took me like 3 years to get $20. So there you go. Have you guys had enough time to take care of the Lewis structures. Remember, you've got to do the totals, or else just silly mistakes creep in. One thing I couldn't work out about Discord was you don't keep the video after it's done, right? Because the good thing about this is that if someone isn't in the stream, they can just click on the link and it will play like a video. But I don't think Discord does that. Right. I've got the beginnings of most of these. But I haven't done the outer electrons and that sort of thing. But hopefully you're all good to check them off. Yeah. So the first one, what I have done with mine is that I'm sort of taking the pro line, and that you just draw the shared electrons as a bond from the very beginning. It just makes it look a little bit neater. You don't have to do that, but every time I've got a stick, there's 2 electrons inside every single one of those sticks. Okay. I've actually done the first one completely. Okay, those 2 fluorines have both got 8 electrons, because remember the stick is a pair. 14 valence electrons. It's finished. HCl, I'm up to about step 3, I think. So I've joined the atoms together, but I need to chuck in my valence electrons. I might use a thin pen for this. I've got 6 left. So the H can't have any more. 2, 4, 6. Down to 0. Check my shells. H has got 2. Cl's got 8. Done. NH3. I'll put the N in the middle because it's unique. There's only one of them. 3 H's bonded. I've used up 6 electrons just to glue everything together, so I've got 2 left. I can't. The camera's kind of freaking out a little bit, I can't put anything on the H's because 1 bond is all they ever need. So the last 2 electrons actually have to go on like a little hat on the N. Goes down to 0. I check my shells. Well, the H's are already happy, and that N 2, 4, 6, 8 electrons. Easy. CF4. Add up my electrons. I get 32. Okay, which is quite a lot. I use 8 just to glue everything together, so there's 24 left. Okay, there's 2, 4, 6, 8 already in the picture, and 24 left. If I just start filling up these F's, and it doesn't actually matter which one I start with, because the whole thing can be just rotated around anyways. Fill them up, fill them up. That's 6, 12, 18 extras. 24 extras. It's finished. Okay, everything's got 8 electrons inside it. I've got the exact right number of electrons. It has to be correct. Yeah. Next one, CH3Cl, total of 14 valence electrons. Sounds right? Yeah. 4, 3 sets of 1s and a 7. Okay. I put it together. The Cl goes in the middle. Sorry, the C goes in the middle. Okay. The reason why I know the C goes in the middle is that, well, out of the C and the Cl, Cs can fit 4 more electrons in their outer shells. Okay, whereas chlorine with 7 electrons already can only fit 1. Okay, so the C has got the most room in the outer shell, it goes in the middle. Okay, pretty much if you see a C in the structure, it's going to go in the middle. Okay, I've used up 2, 4, 6, 8 electrons, so that means there's 6 left. I can't put any on the H's because they're full, so I just fill up this guy, and it's done. Anyone get 100% correct? They are those are pretty straightforward examples, I guess. If you have finished those, the next set are on page 21 of the slideshow. You could just bring it up if you wanted to. Yeah, 100%. Nice one. Yeah, it's probably easily 30 seconds behind what I say and what you type. Okay, so I'm going to flick the screen across off there to my desktop. There he is. Okay, present. Hello. Oh, okay. Why won't you present? There you go. Okay, 4 more. The last one, if you've done that, then the next set is like page 24, 27, or 29, something like that. If you scroll through the slides, there's a total of 4 different slides with Lewis structures, and there's a little trick about the last set. So go to the slide beforehand and read that before you try the last set. Okay, but see if we can just match out these guys. CF4 gotcha. Yeah, it's about keeping track of the numbers. It's really easy to miscount when you do this, especially when you got a lot of electrons like with CF4. But yeah, if you do it wrong, then often the electron shells aren't full anyways. So then you got to go back and check. Okay. Have you done that 5 minutes of class? I don't know what you mean, Liam. Oh yeah, that's right. Yeah, I know. Do you guys know if there'd be like a trick so that the so I could like reduce the lag time? I don't know. Or maybe I could like drop my resolution a little bit or something. Yeah, I guess so. There's probably a setting where I could like lower the frame rate or something a little bit or something like that. I don't know. Yeah, probably right. I could drop it to like 25 FPS, I guess. Maybe I'll try. I don't know. If we have to do it again, I'll try a few things. Everyone getting through those all right? The last one's got like a little bit of a trick to it, I guess. Top three, pretty similar to what we had before, right? If you have done those, it will be good for next lesson for people to have a set of these guys done as well. I will give you a little bit of a heads up. I think we possibly have done a couple of these. I've already done that one. Yeah. Okay. I will give you a bit of a heads up. This is a very multiple bond heavy section. Like there's lots of doubles. There's a few triples in there as well, I think. And then the last two are a little bit funky. Before those two, have a little look at what this slide is telling you. Okay, the slide before number 28. It gives you like a little bit of a hint about a pattern inside our numbers. Is that the one we're up to now? Yeah, it is. Okay, so we're pretty much sorted. Okay, so if I click ahead, I'm pretty sure I have all the Lewis structures for these on here. Here we go. Okay, PCl3, put the P in the middle, 3 Cls around the outside with 26 electrons. You fill up these guys, and then the P gets like a little pair of electrons as a hat on top. Okay, H2S is actually basically the same as H2O, isn't it? Okay, 8 valence electrons, you put the S in the middle, and then there's a pair of electrons top and bottom, 2 bonds. Pretty straightforward, right? Okay, CH2Cl2. Oh yeah, one heads up about this is that the who goes left and who goes right and who goes up and who goes down, it doesn't matter. Okay, so if you put your two CLs left and right and your H's up and down, it's the same thing. Okay, similarly, if you make your CLs go like an L shape, it's just as good as well. Okay, so the two CLs, this one, they could be there and there, or the two CLs, I mean, it could be here and it could come out as a right angle. Okay, the positions don't matter. Okay, CH3OH, the thing about that is that the fact that one of those H's, yeah, true, one of those H's is attached next to an O means that in the Lewis structure, one of those H's comes off the O, so it looks like that. Okay, but we have just hit 12, so I'll see you tomorrow back for regular sort of programming. In fact, I'll see you tomorrow for your titration internal. Don't worry about it. Just follow the instructions. Do what you know. Do what you know. Do the stuff that you practice. You'll be fine. Okay. I'll see you guys around.